lecture, we're going to look at if statements, and we'll see how computers use if statements to make decisions and execute different sequences of code based on the outcomes of these decisions. So at the end of this lecture, you should be able to understand control structures, understand decision structures and how they're used, understand comparison operators, which are made up of relational and logical operators. Okay? No, understand comparison operators. Okay. Anyway, so we've said if statements allow you to make decisions or allow the computer to make decisions and execute code depending on the outcome of this decision. Now, just to take a simple example that we see in our everyday lives. So let's say, for example, before you leave to go for campus, you want to check the weather. And you want to check the weather, and depending on what you decide, you want to know whether to take your raincoat or not. So you ask a question: is it raining? Now, depending on the outcome of this, you can do one of two things. So you say, if it is, then you take your raincoat. If it's not raining, then you leave your raincoat. Okay. So in computers, if we're to look at this diagram on the right, this question that you're asking, is referred to as a condition. Now, the yes or no, evaluates to true or false. So that's how computers process essentially yes and no. So these true and false are referred to as Boolean expressions. Yeah. So yes. So we're saying we want to execute a certain sequence of code depending on the outcome of this condition. So we're saying execute the if code if the condition is true, and execute the else code if the condition is false. And when all is said and done, then you go to the end of the execution, or you execute the next line of code. Now, this is an interesting diagram that you'll see when you're looking at activity diagrams. Now, this just allows you to just show the logical steps that are followed when executing code, or when determining the outcome of decisions. Okay. So now, what control structures are, they just control the way your code is executed, or the logical flow of execution that your program follows. So it's not very useful to have all the statements within your program executing in order. You want to add logic to the way your code is executed. Like, you wanna add you want to have a structure, like a proper structure, that is followed when executing code. So if statements allow you to ask questions or have conditions, and then pick and choose the code statements that you want to execute based on the outcomes of these conditions. And that's what we're going to be doing today. Like, we're going to unpack the different ways that code is executed, and how you actually get to pick and choose what is executed. So another way of controlling the way a program executes is through repetition, and this is where for loops and while loops come in. Now, unfortunately, we're not going to be able to cover these during the course because of time, but if we do find time to, then I'll try to squeeze them in towards the end. But anyway, we just want to make sure that we cover the necessary topics, or the topics that are more relevant to your prac exam than others. So with this repetition structure, it's just a way to do the same thing over and over and over again, and that's what, as we all know, computers are very, very efficient at. So just to sum up these different control structures that we have, you can execute your code sequentially, like one after the other, but then this is not very useful, because again, again, you wanna just add a better structure to to your code execution, and we'll see the selection structure and how if statements allow us to do that. And then one way that we're not going to see, but we might just repetition structures where same code is repeated over and over again and again and again. Okay, so the selection structure. Um, okay, if we just look at this example that we have here, so we're saying if you're over 18 years old. So with this, the question that we're asking is, are you 18 years old? If yes, then you may drive a car. Then if no, then you may not drive a car. And to support this selection, how you choose that, okay, the user can drive a car or not, then yeah, so we look at if statements, and yeah, that's one of the statements that we'll look at to see how you support that. And then the other statement that we might look at next week, that's switch statements, and how yeah, these just use cases to determine to evaluate. Okay, so they use cases to determine, the code that gets executed. Okay, we'll see this later. I think it'll actually be very interesting to cover these. But yes, okay, so let's just look at the if statement and how it's structured. So this is the syntax of an if statement, where you have the if keyword that, and JavaScript uses it to know that, oh, okay, you're about to make a decision. And yeah, so just to get the syntax of an if statement, you have the condition. That is the question you're asking, enclosed within parentheses or brackets. And then you have the statements that you want to execute, or that the sequence of code that you want to execute if the condition is true. Then that is enclosed within the curly brackets. And again, we saw with functions, these curly brackets allow you to determine like the scope, or to create blocks within your program, for the different code that you want to execute. Okay, so with this, what we're trying to say is, if the condition is true, then evaluate statements or execute statements. Otherwise, if the condition is false, then you're going to skip and go to the next line of code that follows the closing curly bracket. Okay, so again, you're asking a question. If the answer is yes, then do statements. If it's no, then don't do anything. Move on to the next. Okay, so now we have comparison operators, and these just allow you to make better decisions. And where you have variables on the left compared to the variables on the right, and then the overall expression is evaluated to okay, the overall expression is evaluated, and then you will know the code, or the piece of code to execute, depending on what this condition evaluates to. Okay, we'll see examples of these as we go along, but let's just try to get a better understanding of these different types of comparison operators that you have. Okay, I'm sure we've seen relational operators from probably, yeah, from maths and stuff. But anyway, the first operator is the greater than. You want to check if the variable on the left is greater than the variable on the right. And then the next one, if the variable on the left is greater or equal to the variable on the right. And then the next one, you want to test for equivalence. Are they the same? Now, if you notice here, you have an equal sign. We saw this operator when we were looking at variables. Now, the assignment operator, where you have, let's say for example, to the population variable. Mari here, when we're actually comparing, then you use two equal signs because you want to test if variables are the same or not. And then that's when the next operator that you get is the not equal to or not equivalent to, and where you use an exclamation mark, and we see less than or equal to and the less than. Okay, now logical operators. These might be a bit tricky to understand, but I'll try to unpack them the best way that I can. Okay, so basically, you have and, or, and not. Okay, so we'll see with examples how these are evaluated, or how these are used to add logic to the way you make decisions. Okay. Okay. So with relational operators, the first example that we have here, we're asking, is 10 equal to 6? And because they're not equal, we know that that answer is false. And then the next one that we have, we're asking, is 10 greater than 6? And we know that that is true, it is, then the overall expression evaluates to true. Okay, so this one here, you're asking if 10 is greater or equal to 10. Now, because of the equal to relationship, then we evaluate this to true because 10 is greater or equal to 10. Okay, we'll see this when we're looking at logical operators, because this greater or equal to, uses the or operator. Okay, and this one, as 10 less than 6, then we know that it's not, therefore the overall expression evaluates to false. And then we have 10, we ask, is 10 less than or equal to 10? And we know that it is true because of the equal to side of the operator. Again, we'll see this when we're looking at logical operators, and we'll try to unpack this in a way that we'll understand. Okay, and then we ask, is 10 not equal to 6? And we'll know that it's not, therefore it is true. Okay, now logical operators. Let us look at this example, and then we'll see how these different comparisons are made. So in the first row of the table on the right, the green one, we ask, is 2 greater than 1? And we know that it's true. And then on the right hand side, we ask, is 3 less than 4? And then we know that it is true. So you have true on the left hand side, you have true on the right hand side. If we're to move over to the table on the left hand side, we see that the first expression, the 2 greater than 1, is x. We can call it x. Then we can call the expression on the right, where you ask, is 3 less than or equal to 4, y? So we have x, which is the first expression, is true. And then we have y, which is the expression on the right hand side, is true. And then now we look at the overall outcome that you get from the expression of ANDing both variables. So we see here, if x is true and y is true, then the overall expression evaluates to true. Therefore, the result is true. And then we do the same thing with the next example. We ask, is 4 less than 3? And we know that it is not. Therefore, the expression on the left hand side evaluates to false. Then we go to the right hand side and ask, is 2 equal to 1? And we know that it's not. So we move to the table, and we see that the x in this example is false, and we see that the y in this example is false. And we know that when we OR false and false, the overall expression is false. Okay, so next example, we ask, is 3 not equal to 3? And then we know to the table, and then we ask, okay, well, and then we see, okay, so if you have a false and you have a false and you OR them, then the overall result is false. Okay, so then now this next example, we're testing for equality. We ask, is 3 equal to 3? And we know that it is true. However, when we say not, we are negating this statement or this expression. So when you negate a true, you get a false. So you're saying something that is not true is false. And then the overall expression evaluates to false. And then with the last example that we have here, we ask, is 2 greater than 5? And we know that it is not. So this 2 greater than 5 evaluates to false. However, you're negating this expression and you're saying not false is true. That's why the overall expression evaluates to true. Okay, so hopefully you were able to follow the different examples that we have, and just to get a better understanding of the different logical operators that we have and the different expressions and their results that come about and the results that come about. But just to trick here with the and and the or, if you're ending variables and one of them is false, then we know that the overall expression evaluates to false. And if you oring two variables and one of them is true, then we know that the overall expression evaluates to true. Okay, so okay, so okay, so she's trying to think of an example, a real world example that we can follow. But yeah, okay, let's do this. So let's say I have fruits that I want to give you. Yeah, I tell you that there's an apple and there's an orange, and I ask you, which do you want? Or yeah, which do you want? And then you tell me, I want an apple and an orange. So just by what you say, you want an apple and an orange, I know that you want both of them. Okay, so you want an apple and an orange. Okay, so both of them, yes. And then we know that. Okay, then I'll know that I'll have to give you both fruits. Now, okay, I ask you again, which do you want? And then you say, I want either an apple or an orange. So when you say that to me, I know that I can give you either one. So you'd be happy with either one that I give you. Okay, so so yeah. So at the end of the day, you get an apple. Okay. So let's just try to let me just try to bring this analogy together. But I'm bad at analogies. But anyway, let's do this. Okay. So when you say you want an apple and an orange, then you want them both. So therefore, at the end of the day, you get both fruits, and then you see that it's true. You get an apple. You get both fruits. Whereas if you say you want an apple or an orange, you're choosing between these ones. Like either one is fine. That's why with an or, when one of the variables is true, then the whole thing evaluates to true because either one, Whereas if you say and, you say all or nothing type thing. That's why when you have a false with an and, the whole thing evaluates to false. Okay, so hopefully you're able to understand how these relate, but then we'll see with more examples and with more practice, how these logical operators are used. Okay, cool. All right. So here we see the else statement. So when we for it to go back to our to this diagram that we have here, so we say okay, we have a condition, né? portion, that's what's executed in the else code. We're saying otherwise you must take the bus. Okay, so if you to go back to this example again, when the condition is if you're 18 over 18 and it is true, then if code we saying then you may drive a car. However, or otherwise, if you're not 18, if you're still young, then you take the bus. Okay, so that's how an else statement is to, to pick, is used in conjunction with the if statement to pick and choose the statements or the code that you're executing. So this is the syntax of the else statement. So you have your condition, and we're saying if the condition is true, then we want to execute statements. However, or otherwise, if the condition is false, then we want to execute the statement within the else block. Okay, so yeah, this is just how to use if and else to pick and choose the code that you want to execute. Now, what if we want to decide between different conditions? What if we just want to ask different things. Now, in such a scenario, this is where we see the else if statement. So you where you have multiple conditions and you want to execute code accordingly. Okay, so in the first if, the if, so we're saying if the condition is true, then we execute the first statement. However, if the condition is false, then we go to the else if. So we're asking what other condition can we meet? And then it says else if this condition in the second line is false, then we move on to the else if, to this else if here. And then we're saying if this else if the condition is false, then we move to this else statement here, where all of these conditions have not been met. So if it's true, then it goes in. If it's not true, then it goes out. And you test the conditions just like that. Now this one will catch all the, it will like execute any, the code here if these different conditions are not met. Okay, so we'll just see this. We'll see this shortly when we apply this the stuff that we're learning. Now, if you have complex conditions that you want to handle, or you want to have decisions within decisions, then you use the nested if statements. Okay, so this if statement here. So you're saying if this one is true, then go inside and execute this one. And if this one is true, then go inside and else execute this one. However, if this one is false, then go inside and execute this one. But if the outer if condition evaluates to false, then you go to the end. So we first evaluate this condition here, the outer one, and then we evaluate the condition inside. Cool. Now, okay, so here's a test question for you that you can do on your own, just to see how well you understand the stuff we learned from this lecture, and just unpack it. Unpack it bit by bit, and then see which of these statements would be executed. Okay, you're welcome to pause it at this point, because I'm gonna look at an application question that will allow us to put everything together. Okay, so here's the question, or rather, this is just a description of the question. We want to determine the BMI of a person, the body mass index. Now this is determined, if the person knows their weight in kgs and height in meters, height squared in meters. Okay, in our case, BMI is calculated by dividing the weight by the height squared. Okay, now depending on the value that we get of this BMI, we want to classify the user. So we're saying, or the person. So we're saying if the BMI is less than 18.5, then the person is classified as underweight. Saying if the BMI falls within this range between 18.5 and 25, then we want to classify this person as ideal. If the BMI is between 25 and 30, then we want to classify this person as overweight. And if the BMI is between 30 and 40, then we want to classify this person as obese. And if the BMI is greater than 40, then we want to classify this person as very obese. Okay, so this is just a question that will allow us to see how if statements are used in real world examples. Okay. So if you go to our Visual Studio here, have an HTML page where we just link our JavaScript file, and this is the function. Okay, so this function doesn't take any parameters. So we want to prompt the user for their weight and their height, and in the prompt we specify the units for the calculation. So we want them to enter their weight in kilograms and their height in meters. And then using these values that the user enters, we want to calculate the BMI. And then depending on the value of the BMI that we get, we want to be able to classify them, and we're going to use if statements to do this classification. Now before we get to the if statements, notice here that we have one classify string variable that we're going to use to store the value of the BMI classification. Now we only have one variable because we only want one classification. We are just evaluating the BMI according to these different values, and then classify. Just have one classification. Just say, okay, this is the BMI category that you fall under. Okay, so the first case we're saying if the BMI is less than 18.5, then we want to classify the person as underweight. So here we see the less than operator. And then else if, because we're evaluating, we want to decide between different conditions, then we use the else if. And then we say if the BMI is greater or equal to 18.5, and if the BMI is less than or equal to 25. Now we're using an and here because we have a range. If we were to go back to our chart, it gives us a range. So we have a range within which the BMI value falls. So that's why we're using an and. We want to make sure that the value is strictly within this range, and then we want to classify them as ideal. And then the other condition that we want to test is if it falls between 25 and if it's greater than 25, and if it's less than or equal to 30, then we want to classify them as overweight. And if it's greater than 30, and if it's less than or equal to 40, then we want to classify them as obese. Otherwise, if none of these conditions are met, if it's greater than 40, then we want to classify the person as very obese. Now this else statement is only executed if and only if all of these different conditions that we have evaluate to false. Now if they evaluate to true, then the different classifier will be the value for classifier will be given accordingly. Okay, then at the end of this, when we're done evaluating the condition and updating the classify variable, then we want to alert the user of the BMI. It's output to 2 decimal places using the toFixed method, and then we say, okay, we give them the classification, and then here we do the function call. Okay, so yes, this is that. I may have been careless with the different ranges, but just to double check, here we're saying less than, so less than, so this equal to operator here, equal to portion of this operator will handle a case should we get a BMI value of 18.5. So yeah, that's cool. Okay, let's run this and then see what happens. Okay, so we enter our weight in kilograms, and then our height, because we're really tall, and then we get our BMI value, and then we get the classification, and then that's it for this question, or for this lecture. And okay, stop that. Okay, that's it for this lecture. You're welcome to try this on your own and see if, without looking at my solution here, see if you'll be able to classify the user's BMI according to the chart, and the different values that you get for the different test cases that you'll give it. Okay.